All right, we're going to solve this, but let's first establish what are we actually dealing with here. We have a root of 2 multiplied by a root more of 2 squared. Inside it's a root more 2 cubed. Inside there is a root more 2 power to the 4th. And this is repeating, so we'll take a root more 2 power to the 5, to the 6th, to the 7th, and we'll continue that unlimited. We'll calculate this today, and the first we'll do is that we will try to rewrite these up in a different ways. First of all, we'll see that when we have these roots, we can put them outside of each other. So we have square root of 2 multiplied by square root of 2 squared. Remember that this root is inside the other root, and multiplied by square root of 2 cubed, multiplied by, again, now we have 4 roots, and I will stop there because I'm pretty sure you get the picture after this cube, so I'll just leave 3 dots, which means that this continues out indefinitely. So how can we rewrite this in another way? Well, if we have 2 power to a half, that's another way of writing the square root of 2, and this is the square root and the square root. So this is 2 squared power to a half multiplied by a half, and that is actually what we're doing. So it's the same here, 2 cubed power to a half cubed, and multiplied by 2 power to the 4th power to a half power to the 4th. So again, we can rewrite this as 2 power to a half. This will be 1/4, and we'll use the roots of power to multiply by 2. So this will be 2/4. 2 power to 2/4 multiplied by 2 power to, this will be 1/8. So 3/8. 3/8. And again, we will have 16 over 4/16. So multiplied by 2 power to 4/16. And I know, many of you will probably think, well, these fractions, we could rewrite those in another way, and we could, but there's actually a point in keeping them this way, and I'll show you now, because when we have this is the same as writing 2 power to a half plus 2/4 plus 3/8 plus 4/16. And if we forget this for a moment, this 2, and we'll just look at this, we will notice that this is actually a sequence, and we can calculate what the sum is of this. So if we look at this sum, 1/4 plus 2/4 plus 3/8 plus 4/16 plus, and just continue. Oh, there was a dot too many, but if we look at this, well, this reminds us of a series we know, and well, you might not know it, but now I'll tell you that if we had, this should be a 2. So if we had a series called 1/2 plus 1/4 plus 1/8 plus 4/16, and that that should be a 1 as well, we would know that this would be the first number, a half, over 1 minus the first number as well, a half. So if we calculate this, we'll see that this will be half over half, and this is equal to 1. All right, so if we look at this, we know that if we had this, I'll just go down and get some more space on my blackboard here. So if we had this, well, then it would be 1. But we have more than that. We also, because what we're missing here, we can see that we are missing the 2 here. So actually we can create a row more where this is not a part of it. So 1/4 plus 1/8 plus 1/16. Again, continues. But if we look at this, well, this must be this sequence just minus 1/2 over here. So if we write it up like we had here, I will try to show it as sequence because this is the same. Well, how do we subtract 1/2 from this? Well, we can subtract 1/4 up here. That would be 1/2 if we divide it. So this will be 1/4 over 1/2. With good reason, you could ask, well, why didn't you just write 1/2? Because you know there was 1 minus 1/2. Well, it gives a meaning in a bit because we are looking at a system here. We're looking at a system we can use in a bit. So again, we can make another sequence 1/8 plus 1/16. Well, if we look at this, this is the same as this one, just without 1/4. So now we'll have 1/4 divided by 1/2, and then we can again subtract the half of this, which is 1/8. So this will be 1/8 divided by 1/2. All right, and I hope you can see the system because we could do the same here, and we would. Now I'll not write a long sequence here, but we could do the same here, and we would end with 1/16 over 1/2. So if I want to look, and that's what I want to see what this is, well, I'll just change the color right here. We can see, well, this must be equal to all of these sums together. So this must be equal to 1/2. All of this will be divided by the 1/2 because now we have a common denominator, so we can just add all these. Plus 1/4 plus 1/8 plus 1/16 plus etc. etc. And well, what is this? Well, that's this series. That's the geometric series we used before, which we knew gave 1. So the numerator gives 1. So that's 1/1/2. This is equal to 2. Now you may think this is the solution, but remember that this was the exponent, and even though this is a bit of a mess now, this was the one we needed to calculate. So the real result is actually 2 power to the sequence we just figured out. So 2 power to 2, which is equal to 4. So the solution is 4. Thank you for watching. Please like the video so it can spread to more people. Please subscribe if you want to see more of my videos. Please watch this playlist, and if you want a little challenge, try to see if you can find the mistake I make right up here without looking at the comments. Thank you for watching again.